Good morning, everyone, and welcome to today's class. In today's class, we are supposed to do equations of motion. And if you remember, we have done certain problems in the previous class where the car was moving and we had to find out in how much distance it will stop and all that. We had done some basic problems. Yes or no? Do we remember these problems? Okay, in today's class, we will go ahead and do some more problems. Remember, the more the problems that you do better, the better are your chances that similar problem will appear in the examination hall and you would be able to solve them. This is the first problem that I'm going to do. This is again from one of your previous exams. This has come multiple times in many exams. Multiple times. May not be the same second. May not be the same second, but different seconds they ask you this question. So this is the question: a body starts from rest. Normally the body will start from rest, so that calculation is simple. A body starts from rest. What is the ratio of the distance traveled in the fourth and the third second? This is how this problem is framed. So let us see if you can solve this one. I'll give you 2 minutes to solve it. Do we have the answer for this one, bacha? Okay. Yes, do we have the answer?
B.
B, 5 by 7. That means in the fourth second he will travel less, and in the third second he will travel more. Fourth and the third, it is not third and the fourth. It is fourth and the third.
A, sir.
A, sir. Remember, read the question carefully, beta, because the only thing they can do is they can just change the order and your answer becomes reverse. If the question was third and the fourth, it was 7, it was 5:7. If it is fourth and third, it is 7:5. Do we understand this? Which formula are we going to apply here? Fatafat, we will do it. Displacement in the nth second will be equal to u plus a by 2 times 2n minus 1. I hope you all understand this formula now. Now here the body, as you can see, starts from rest. So u is going to be 0. So I can just write, or I can just see that this displacement is proportional to 2 times n minus 1, because this acceleration is constant. Do we understand this? So displacement will be proportional to 2n minus 1. That means displacement in the seventh, oops, displacement in the 7th second will be equal to, if I write equal to, it will be equal to a by 2 into 2 into 7 minus 1. Yes or no? And displacement in the 5th second will be equal to a by 2 is same, so it just gets cancelled. 2 into 5 minus 1. Yes or no? Then you can find the ratio of displacement in the 7th second. Why I'm writing 7? It's 4 and 3. Oops. Mistake. Everyone can make a mistake. See, even I, looking at your answer, I wrote 7 and 5. Okay, displacement in the 4th second, 2 into 4 minus 1. Displacement in the 3rd second, 2 into 3 minus 1. When I was writing the ratio, then I realized that I'm finding the wrong ratio. Okay, so displacement in the 4th second divided by displacement in the 3rd second, that will be equal to 8. 4 into 2, 8 minus 1, 7. 7 divided by 5. Do we understand this, everyone? Okay, well done. Remember, the more the number of problems you solve, the more are the chances that same problem will come in the examination hall, and similar problems will definitely come. I will try to cover each and every problem that can come or has previously come, because the problem that has previously come will also come, and that is the next question. So fatafat, quickly look at the question, solve it, and give me the answer as soon as possible. I'll give you 2 minutes to do this. A body having an initial velocity 0 is moving with uniform acceleration of 8 meter per second square. The distance traveled in the 5th second is. And what is the answer for this one?
Six meters, sir.
36 meters, sir, and that is correct, sir. 36 meter. That is correct. So how are we supposed to do it? Again, I will write the formula once again. Displacement in the nth second is u plus a by 2 times 2n minus 1. Here it is given that the initial velocity is 0. So this u, normally that is the question. with initial velocity 0, that should come in your exam. So remember that displacement in the nth second, we have to find out the displacement in the fifth second. So we just put it for the fifth second. Displacement in the fifth second will be equal to 0. Initial velocity is 0 plus acceleration is 8. 8 by 2. 2 into 5 minus 1. 2 into 5 is 10. 10 minus 1 is 9. 9 multiplied by 4. I think the answer is 36 meters. Do we get this? Yes or no? No, yes. Everyone understand this? Okay. Please remember this. I hope that similar question will come in your exam because they are more likely to come. I've seen many a times questions like this. Can you move ahead in life? Again, one question can come if they make the paper slightly difficult. So this is a question that is supposed to come if the paper becomes slightly difficult. So have you written the previous one? Comes the next one, and this is the next one. I have forgotten which question number is this, so I will just give it an arbit. I think it was 2. Question number 3. A body travels for 15 seconds starting from rest with constant acceleration. It travels distance s1, s2, and s3 in the first 5, second 5, in the next 5. Relation between s1, s2, and s3, and I'll give you 2 minutes to solve this. Yes, beta. Any answers that you got? Yes or no? Do you want more time or do you want me to solve it? When you get answers, everyone is very keen to reply. When you don't get answers, no one is keen to reply. Why is that so? Not getting answer does not make you any less, or getting answer does not make you any more. So, tell me, do you want to try or should I do it for you? Huh? Should I do it? If you had to guess, an intelligent guess, let's play Kaun Banega Crorepati, and I sit on that seat and you sit on the hot seat. If you had to guess, make an intelligent guess, looking at the option, which option would you choose? Remember, the guess must be intelligent, it must have some logic. Which option do you think is correct? Making an intelligent guess, a calculated intelligent guess. Yes, my dear friends. Option one. What makes you feel that option one? The only reason that can make you feel option one is that all the time intervals are same. Yes or no? That might be the only reason. But you forget the fact that it is moving with a constant acceleration. So its velocity is not same. Its velocity is continuously increasing. Now, apply more logic. If its velocity is continuously increasing, in which period it will travel the least? In which period it will travel the least? First 5 seconds, next 5, or the next 5? In which 5 seconds will it travel the least? It will travel least in this 5. Yes or no? Yes or no? It will travel the maximum in this. Yes or no? Yes or no? It will travel least in the first 5. So S1 will be smallest and S3 will be largest. Now you can tell me the answer without even solving anything. In the first 5 seconds, it will be traveling the least. In the last 5 seconds, because it is constant acceleration, it will travel maximum. S1 is least, S3 is most, S3 is the largest. I don't have to solve anything. I can say the answer straight away, and the answer is going to be option C. S1 is the smallest, then it is S3, and then it is S5. Do we understand this? Option number B and option number D are also there. Option number D is not possible because in option number D, S2 is more than S3. Option number B is possible. So the correct option can be from option number B, because option number B, S1 is smallest and S3 is largest. Okay, so the only confusion should be between this option and this option. So 50-50% chance. But if you had to solve it in the correct way, how are you going to solve it in the correct way? So you will draw, assume that it is moving like this. This is point A, this is point B, this is point C, this is point D. At point A, the velocity is 0. So I write it like this. Now, from A to C, the time it takes is 5 seconds. From C to D, the time it takes is 5 seconds. From D to B, the time it takes is 5 seconds. Do we understand this? All the three are having the same interval of time, 5 seconds. What do we know about their displacement? If I call the displacement from A to C, it is S1. If I call it from C to D, it is S2. If I call it from D to B, it is S3. Do we understand this? Now I will make the first equation from A to C. If I make the first equation from A to C, you can see initial velocity is given, which is 0. Time is given, 5 seconds, and displacement is given, S1. Time, displacement, and initial velocity. Which equation should I use? 1, 2, or 3? 1, 2, or 3? Which equation should I use? 1, 2, or 3? Displacement, time, and initial velocity. Which equation should I use? 1, 2, or 3? Equation number 2. Displacement is ut plus half at square. I am not writing the equation. I am straight away writing the displacement. Displacement is S1. Yes or no? Initial velocity is 0. So 0 plus half. Acceleration is given as constant. So half A into time from A to C. Time is 5 seconds ka square. So my S1 becomes 25 A by 2. Do we all understand this? Yes or no? No, yes. Now I move on to the next segment from C to D. But the problem from C to D, if you understand, I don't know the velocity at point C. I don't know the velocity at point C. To find out the velocity for point C, I will again have to go back from A to B. That will make the question lengthy. I don't want it to become lengthy. So what will I do? I will make the equation straight away from A to D. Why I can do this? Because from A to D, the acceleration is constant. If the acceleration is constant, you can make equation from any point to any point. Do we understand this? Yes or no? So now I make equation from A to D. What is the displacement? Look at the diagram and tell me what is the displacement from A to D. From A to D, what is the displacement? Tell me, bacha. A to D. Displacement becomes S1 plus S2. Yes or no? No, yes. Half. Acceleration is A. How much is the time from A to D? It is 10 seconds. 5 plus 5, 10. Yes or no? So my S1 plus S2 becomes half into A into 10 square. So it becomes 100 A by 10. Yes or no? 100 A by 2. Yes or no? I already know the value of S1. So now I can straight away find the value of S2 by subtracting it. I think I will get 75 A by 2. That is, my dear friends. That is, my dear friends. That is, my dear friends, the value of S2. As soon as you get the value of S2, you can mark this as the correct answer. You don't have to do the third step because you can see S1 is 1/3 of S2. Even though you can find out the answer, I will tell you how to do it. What is the next step that you are going to do? From where to where you are going to make equation? Can you make that equation for me? From where to where are you going to make the equation? Again, if I try to make the equation from D to B, I don't know the velocity at D. So what will I do? I will make the equation from, I will still make the equation from A to B. Do we understand this? I will still make the equation from A to B. Now, if you look at the displacement, it is S1 plus S2 plus S3. That will be equal to half into acceleration into time now becomes 15 square. So my S1 plus S2 plus S3 becomes 15 square is 225. 225 A by 2. I already know the value of S1 plus S2 from the previous equation. I can put that value and get the value of S3. I think the value of S3 is going to come as 125 by 2A. Now I can find out which is the correct option. S3 is 5 times of A. S3 is 5 times of S1 and S2 is 3 times of S1. The correct option still remains option C. Do we understand this? Yes or no? How I have done this? Remember this concept that if you have constant acceleration, you can write it as a note. For constant acceleration, equation can be made from one point to the other point, any point to the other, any point. I'll give you 2 minutes to note this down. Have you noted it down, bacha? Have you understood it, beta? Can you move on to the next question, please? Okay, here comes the next one, and I'll give you 2 minutes to solve this. The question is very simple. I have forgotten the number, so I'll write it as question number 5. A particle moving rectilinearly, means in a straight line, with constant acceleration is having initial velocity as 10 meter per second. After some time, time is not given, the velocity becomes 30 meter per second. Find out the velocity at the midpoint of its path. So you have to find out what is the velocity of this object at the midpoint, and you will have 2 minutes to solve it. So, bacha, have you done this? Yes or no? No, yes. Shall I help you out? Okay. So, how are we supposed to do this? Again, I draw a pretty simple diagram. And remember, I don't know, I feel that this type of question can come in the examination hall. A to B, this body is moving. Remember, it is moving with constant acceleration. So, at point A, it is given the velocity is 10 meter per second. At point B, it is given the velocity is 30 meter per second. They are asking you the velocity at the midpoint of its path. So let me call the total distance from A to B or the total displacement as x. Then I make a point C and the displacement from A to C will be x by 2. Yes or no? You are supposed to find out the velocity at point C. Now, how are you going to do this? You know initial velocity, you know final velocity, and you know displacement. Which equation you should use? Initial velocity, final velocity, and displacement. You must use equation number which one? 3. So first I apply from equation from A to B, v square is equal to u square plus 2 times a multiplied by the displacement. Final velocity is 30, so 30 square. That would be equal to initial velocity is 10, so 10 square plus 2 times. I don't know the acceleration, I'll put it as a. Displacement is x, so I'll write it as x. Do we understand this? This is the equation I have made from A to B. Now, what is the next equation that I should make from where to where? It is very simple that the next equation has to be made from A to C. Yes or no? From A to C is the next equation that I am going to make. The initial velocity, I will write the equation for just for remembering it. V square is equal to u square plus 2 times a into displacement. The final velocity is velocity at C. C is the final point. I don't know that, so I'll just call it as V. I'll just call it as V. V square is equal to initial velocity is velocity as A. Velocity at A is 10 meter per second square. So I write it as 10 square plus 2 times A. The displacement here, if you look at the displacement here, is x by 2. Yes or no? So I write it as x by 2. Now from here, what I can do is find the value of ax from this equation. Find the value of ax from this equation. You have to do a bit of maths and then get the value of v. How I'm going to do this? I can write from this equation 30 square minus 10 square divided by 2 is ax. Yes or no? From the right hand side, I can write v square minus 10 square is equal to a into x, because these two things will get cancelled. Yes or no? I can equate the value of a into x from both sides, so I will get 30 square minus 10 square by 2 will be equal to v square minus 10 square. To solve this, you will get v square as 10 square plus 30 square divided by 2. This 10 square minus 10 square goes on this side, plus becomes plus 10 square, and you take the LCM and you get this. So my v, my dear friend, becomes under root of 30 square plus 10 square by 2. That is 900 plus 100, 1000 by 2, 500, root over 500, and root over 500 is 10 times root over 5. Do we understand this? Anyone got how I have done this? Anyone having any doubt, please raise. We understand this. I'll give you 1 minute to note it down, and then I will present the next question for you to solve. Are we ready? Have you noted it down, bacha? Any doubt? Shall we move on to the next question? Okay. Here comes the next question. I hope everyone is ready, and I'm expecting an answer from all of my kids. Here comes the question. The engine of a train is moving with a uniform acceleration. It passes an electric pole with a velocity u. The last compartment passes the same pole with velocity v. With what velocity the midpoint of the train will pass the same pole? Think about this question. I'll give you 2 minutes to solve it. I'll be back after 2 minutes.
Option B, correct answer. Sir, option B.
Option B. How did you get option B? Guessing? Option B is correct. And this question is exactly same as the question that we did before. Do we understand this? The only reason is it is just put in a different way. It is just put in a different way. Nothing else. It is just put in a different way. If I try to make you understand, see, if I draw a diagram and let us suppose this is my train, this is my engine, and this is my last bogie. And let us say this is my pole. Now, when the engine crosses this pole, this engine is moving with a velocity u. Do we understand this? Now, remember, this train is not moving with a uniform velocity. It is moving with uniform acceleration. So, as soon as the engine crosses the pole, the velocity of the engine changes. Now, look at the instant where the last bogie crosses the pole. The pole has not moved. I just shifted the pole just to make you understand. When the last bogie crosses the pole, it is moving with a velocity v. At the same time, the engine should also move with the velocity v. Yes or no? So basically, this question is simply if the length of the train is taken as x, when the entire train crosses the pole, the velocity of the train is v. When the engine crosses the pole, the velocity is u. Yes or no? Then they are basically asking you what is the velocity of the engine or the velocity of the train when it has only crossed half of the train. So basically they are asking you what is the velocity when half of the train crosses the pole. Yes or no? Now you look at the previous option that we had done very extensively, and the previous question was exactly the same, and that is why I wrote the answer in this form. 30 square plus 10 square, so that you get a hint. 30 square plus 10 square. 30 is the final velocity, 10 is the initial velocity, and by 2. Do we understand this? Therefore, you can straight away write by whatever velocity at c will be under root of v square plus u square by 2. I just feel that this type of question can come in your examination hall, in your exam, and that is why I spent so much time in solving this question. Do we understand this, my dear friends? Everyone, I'll give you a quick note on this as well. And that quick note just says the same thing, my dears. Don't have to worry about that. Yes, beta, we understand this, bacha. I hope everyone understands this. Yes or no? No, yes. Just give you a quick note with this, and you can note down this note. I don't want to burden you with a lot of things, but sometimes if you can write it in the form of a note, it might serve a purpose. And this is the note that I am sending it to you. Similar thing, just written in the form of a language. You may not write it in the form of English language. You can write it in the form of any language that you understand. Remember this concept, because a question based on this concept is very likely, that is my intuition, is very likely to come this year. I'll give you 2 minutes to do this. So everyone has noted this down, my dear friends?
Yes, sir.
This concept. Okay. We'll end this class with one more question, and I want my kids to give me the answer as quickly as possible. Remember, we'll do more question of this type after some time, but this is just for this class. It's a straightforward question and it comes on your screen now. A body A moves with uniform acceleration. I have forgotten the question number. Let me call it as 8. Remember, the more the number of questions that you do, my dear friends, the better you are going to become. And same question are going to come. Trust me on that. A body moves with uniform acceleration A and 0 initial velocity. Another body B starts from the same point, moves in the same direction with a constant velocity V. Two bodies meet each other after time T. What is the value of that time? And you have 2 minutes to solve it. Do you have the answer, my dear friends? Yes or no? No, yes. Huh? Draw a simple diagram. Oops. Moving in a straight line. They start, let us say, from this point X. Why I'm calling the point X? Because A and B are used. Gentleman A. For gentleman A, initial velocity is 0 and acceleration is A. Gentleman B moves with a velocity V. Acceleration is 0. Do we understand this? Yes or no? Let us suppose that they meet at this point Y and the distance of this point, let us say, is S. And they meet each other in, let us say, the same time they will meet each other. Yes or no, beta? Time taken is T. So whatever displacement A has got in T seconds, that must be same as the displacement of B in T seconds. Yes or no? Yes or no? Do you understand this? What is the displacement of A? Let us write the equation for A. For A, this S is equal to U. U is 0. Half AT square. Yes or no, my dear friends? What about B? For B, acceleration is 0. So displacement S is equal to ut plus half at square. Acceleration is 0. So this is equal to V multiplied by T. Yes or no? You can equate the two and get the value of time. So half at square will be equal to Vt. You can cut one time because time 0, we already know they are together. The next time is 2V by A, and that is the answer, my dear friends. Do we understand this? Yes or no? No, yes. Anyone has any doubts on this? You understand this? Well, then that was the last question, and I'll give you 1 minute to note it down. We'll meet again in the next class, that is tomorrow. We will start with motion under gravity, similar questions. The only thing is acceleration will not be given. Acceleration is known, and that will be equal to g, and it will be always downward. So I'll see you in the next class. I request you again to solve as many problems. The sheet is there with you. How many of you are solving sheets? Please raise your hands. I was not expecting that. Well done. Please solve the sheets. I can give you in writing that the question in the examination hall will come from that sheet. Please solve it. If you have any doubts, you can always ask them. See you in the next class. Take care. Have a nice day, bacha. Bye bye.